Hi, today we'll be looking at the rate of serious crime through the county demographics. So, the research question we're hoping to answer today is, what is the best linear regression model to predict the rate of serious crime? And is there a most promising predictor? Below are the factors we'll be looking at. So, according to the Bureau of Justice, serious crime or violent crimes are categorized as murder, rape, robbery, and assault. Other crimes like theft and drug abuse is not really considered in this study. Today, as technologies are getting better and better, more and more data are being collected on types and number of crimes across the world. Law enforcement have gradually begun to adopt these techniques to reduce the risk of these crimes. Previous researches include support vector machines, which is a nonlinear model performed well for time series predictions and regression. Fuzzy theory, on the other hand, is another technique that requires less computational efforts and excellent learning capabilities. Artificial neural networks is one of the most trending methods inspired by biological neurons. Lastly, multivariate time series is a tool used to study the behavior of time-dependent data to predict future crime rates. All these are used today in the previous researches that have returned excellent results. The dataset we'll be looking at in the presentation can be obtained from the attached R package titled cdi.csv. The dataset provides selected county demographic information for 300 of the most populous counties in the United States. Each line of the dataset has an identification number with a county name and state's abbreviation, and then information on 14 variables for a single county. The information generally pertains to the year 1990 and 1992. Out of the 17 variables, 12 are continuous, which will be the only ones we'll be considering today. The different types of variables are labeled in the key on the top right corner. The data is clean, meaning that there's no missing values or actions we need to take prior to starting the analysis. I have personally chosen to evaluate the correlation between variables at this stage to most effectively select a subset of the data to start with. Deleting correlated variables is one remedy for multicollinearity, which can make coefficients become very sensitive to small changes in a model. This could cause problems in later stages of model building. The correlation heat plot we see tells us that 3 variables in particular, apart from crime, are cause for concern. These include population, bed, and personal income. I chose to keep physicians because it only correlates with the above variables I have stated, which will be deleted in the future. This discovery makes sense as having a larger population obviously means that there are more doctors, and more doctors logically means that there should be more hospital beds. Once again, refer to the key for the variable types. Here, we see the scatter plots between all 9 variables. We can see area versus crime, percent of young population versus crime, and etc. This is not very helpful as we're looking to find a multilinear regression instead of a simple linear regression. Here is the linear model against all 9 variables. I will refer to each variable from x1 to x9 and y in the presentation. All R code and results, like the one here, can be referred to in the attached R Markdown document. On the right, we see the individual residual plots, which seem to look good. Before we start building the model, we need to look at the 4 assumptions first. Linear regression needs for the relationship between the independent and dependent variable to be linear. It can also be used to check for outliers, which will be targeted later. If we look at the red line, it is very straight, indicating a linear relationship. This tells us that we don't need to look into a polynomial regression. Like stated before, multicollinearity can cause issues later on. After deleting the 3 highly correlated variables, we see that the correlation plot looks a lot better. Specific correlation values can be found in the R Markdown too. To further verify independence, I have ran a variance inflation factor, or VIF, test for each category. As you can see, all values are less than 10, which tells us that none of them are of major concern. The third assumption that needs to be met is the normality assumption. All variables are required to be multivariate normal. A good QQ plot should be very linear. However, here we see that there is a clear upper tail and a lower tail. The Shapiro test is used to officially test this theory. With a p-value less than 2.2 to the negative 16, there's clearly statistically significant evidence to suggest that the data is not normal. Lastly, we want to test the homeoscedasticity, which means that the error term is the same across all values of the independent variable. On the left is the scale location plot. To officially test this assumption, methods like the Goldfield quant test and the Brown-Forsyth test are used. Running a BF test gives an extremely high p-value of 0.9508. This is insufficient evidence to say that this assumption is violated, so we're good over here. Now it's time for us to build the actual model. Overall, the best way to resolve the issue that we have discovered prior for the non-normality is a Box-Cox transformation. Not only does it help with non-normality, it also improves the non-constant issues. Though the Box-Cox procedure, through that, lambda was found to be 0.090909 on a repeat. This works by using the method of maximum likelihood. We will call the new y y prime. If we look at the new QQ plot, we see that the points are much more so on the diagonal line. The Shapiro test also returns a much larger p-value of 0.009349. Although this is still considered statistically significant, it is much better than the previous p-value of 10 to the negative 16. When evaluating the summary of the previous linear regression, there are many variables with p-values greater than 0.05, thus calling into question the validity of the full model. To determine a better model, I ran a best sub, which returns the best subset of variables in their respective R-squared, malloc, AICP, SBCP, and etc. Looking back at our original research question, we want to find the best model to predict the rate of serious crime, telling me to lean more towards looking at the CP and AICP rather than the SBC. The smallest AICP is negative 0.87 in row 5, accompanied by the smallest CP. The corresponding model includes area, percent of young population, physicians, poverty, and per capita income. As you can see, this includes a P of 6. And below, we have the corresponding X values with the meaning of the X values. To test the reduced model, we can run an ANOVA test. As you can see, the p-value is extremely big, telling us that there is no evidence to suggest the percent of old population, high school graduate rate, bachelor's rate, poverty rate, and unemployment have statistically significant improve the fit of the model. On the right, we have the influence plot with the hat values on the x-axis and the studentized residuals on the y-axis. The larger the circle, the more influence the point has. The table on the left shows us exact results of the few of the most influential points. We see that in both table and graph, point 1 causes the most concern. To rectify the situation, we want to do a robust regression. I chose to do the Huber version rather than the bi-squared because the bi-squared had a larger residual standard error. The summary of the final model is shown here. Some values seem to be 0, but they are in fact just very small. Given the degree of freedom of the t-test, the critical value is calculated to be 1.9681. We see that all variables are greater, thus all of them are significant. Remember that this model is built on top of a Box-Cox transformation, so for any predictions we make, we need to back transform the output. The function f shows the procedure for back transformation. We can find the most impactful predictors in many ways, like looking at the change in R-squared when you add a variable and the correlation matrix. Over here, I chose to compare coefficients to select the best predictor. physicians seem to have the highest t value, telling us its importance. If we look at the added variable plots, physicians also has the graph that has the most impact given it's the largest slope. Both tell us that the number of physicians in a country is actually the best predictor for serious crime. This makes sense as more violent crimes equal more injuries. So, in conclusion, what did we do? In this project, we looked at the data, the first determined issue, which is multicollinearity, which we solved by dropping unnecessary variables. We then solved the non-normality issue through the use of box plots. To simplify the model, we looked at AIC and CP to determine the best. Last of all, we analyzed the influential points telling us to do a robust regression. We have successfully discovered that the best linear regression model is a robust regression on area, percent of young population, number of physicians, poverty rate, and per capita income. The best predictor out of them all is in fact the number of physicians, and below is the actual resulting model. What we did today is by no means a perfect model. There are many issues, like the data is still not normal. There are also many limitations due to the complexity of the real world, like error in data gathering or missing variables that might be influential. Compared to other research on serious crime prediction, my method can certainly be improved. For example, neural network researches have more flexible and general functional forms than the traditional statistical methods. One thing going for MLR is the data sets just being 300, which might hinder machine learning training and testing capabilities. It is extremely important to evaluate your data and determine which form of analysis is best suited for you. In the future, I hope to incorporate the categorical variable region into the study. Being Northeast, Midwest, or South could actually have significant impact in the crime rate. Thank you very much for listening to my presentation.